mean value theorem has some other applications where it connects derivative information back to information about the original function. Well, here's a theorem. Suppose the derivative of some function, so I'm assuming it's a differentiable function, is positive, it's greater than 0, on some open interval. Then the function is an increasing function, meaning that it sends bigger inputs to bigger outputs. You probably already believe that statement, but the mean value theorem lets us verify that it's actually true. Okay, so let's prove this result. I'm going to pick 2 points A and B, but I want to make sure that I pick them in order. So I'm going to pick B bigger than A, so I can talk about the interval AB. All right, so I picked my 2 points. Now I'm going to apply the mean value theorem to the open interval AB. And that's okay, because I'm going to pick A and B to be in this open interval, and that means that f, being differentiable, satisfies the conditions of the mean value theorem. It'll be continuous on the closed interval AB, and it'll be differentiable on the open interval AB. Okay, so the mean value theorem then tells me to look at f of b minus f of a over b minus a, and the conclusion is that this is the derivative of f at some mystery point in between a and b. Now the good news is I don't know much about the derivative, but I know the derivative is positive. So I know that f of b minus f of a over b minus a is positive. The other thing that I know is that b is greater than a, and that means the denominator here, b minus a, is also positive. So I've got mystery number divided by positive is positive. That means this numerator must also be positive. So f of b minus f of a is positive. Now if I add f of a to both sides, I get that f of b is bigger than f of a. If f sends bigger inputs to bigger outputs, then f is increasing. Right? Increasing means that a bigger input is sent to a bigger output. So if b is greater than a, then f of b is bigger than f of a. And this argument works for any a and b in the open interval on which I know the derivative is positive. So I'm going to conclude that f is an increasing function, which is exactly what I wanted to show. So if the derivative is positive on a whole interval, then the function's increasing on that interval. But it's important to point out that I needed to know the sign, the SIGN of the derivative on that entire interval. The mean value theorem ends up just picking out a single point, that point C, where it'll examine the derivative. But in order to cover all my bases, right, because I don't know what point C the mean value theorem might make me look at, I've got to control the sign, the SIGN of the derivative on the entire interval. All right, now I can play the same game when the sign of the derivative is negative. So if I know the sign, the SIGN of the derivative is negative on some open interval, then I conclude that f is a decreasing function. And again, this is just an application of the mean value theorem. Let's see the proof. So I'm going to start out by, again, picking 2 points A and B in my open interval. And I'll again pick them so that b is greater than a, so I can talk about the interval AB. And then applying the mean value theorem, I should look at f of b minus f of a over b minus a. And the mean value theorem promises me that this is the derivative at some point. I don't know what c is, but it's the derivative at some point. But I know the derivative at any point is negative, so this must be negative. Now b minus a is positive because b is bigger than a, so I've got a number I don't know divided by a positive number is negative. That means that f of b minus f of a must be negative. Then I add f of a to both sides, and I can conclude that f of b is less than f of a. In other words, f sends bigger inputs to smaller output. Since f sends bigger inputs to smaller outputs, f is a decreasing function. Once again, we're seeing that the mean value theorem lets me relate information about the derivative, in this case the fact that the sign of the derivative is negative, back to information about the original function, in this case the function's decreasing. Alright, well, let's summarize what we've learned thus far. So here are some applications of the mean value theorem. If f is differentiable on some open interval, and depending as to what happens, then we know something about f on that interval. So if the derivative is identically 0, if the derivative is equal to 0 no matter what I plug in, then f is constant on that interval. If the derivative is positive, no matter what I plug in, then f is increasing on that interval. And if the derivative is negative, then f is decreasing on that interval.